Alrighty, we're still here on part 5 and we're interpreting the derivative. Number 3 says the total cost of repaying a student loan at an interest rate of R% per year is C, the total cost, is equal to F of R, meaning R is your input variable. And as R changes, the total cost will change. So what is the meaning of F prime of R? Well, and what are its units? Well, the total cost would be in dollars, and the interest rate, the input variable, is in percent. So it's basically going to be, this derivative is the rate at which the cost of repayment changes with respect to the interest rate. And the interest rate itself is interest per year. So it's going to be effectively dollars per interest rate or interest paid per year. That is going to be the units of this situation. And the meaning is effectively, as your interest rate goes up, the total dollars you will have to pay on your loan goes up, which makes sense. If you're paying more interest, then you're paying more money. So what does F prime of 10 equals 1200 mean? Well, that basically says that at 10% per year interest, the total cost in dollars is increasing. And sorry that I'm speaking slowly to wait for my writing to catch up. Is increasing at $1,200. Okay, and that's per interest percentage per year. Okay, now is F prime of R always positive or does it change sign? Well, it's always positive because as interest goes up, the total cost that you are going to pay goes up. So you can't have a negative change when it costs more money when the interest rates are higher. Number 4 is giving us a table of values, and they say, they say it's an accelerating sports car going from 0 to 60 miles per hour in 5 seconds. And by the way, 88 feet per second is 60 miles per hour. So this is already converted from miles per hour to feet per second, which is awesome. And they want us to find the average acceleration over each of the first 2 seconds. Well, all we have to do there is find the average rate of change in velocity for the first second. So 30 minus 0 over 1 minus 0. So it's going to be 30, and then the units, instead of feet per second, we'll just say feet per second squared. And then next, on the second, we look at these two numbers. So we're looking at the average rate of change from minute 1 to minute 2. So that's 22 over 1, or 22, and still feet per second squared. And then the very last problem here, is this one. The child is inflating a balloon and admires it for a while and lets the air go out at a constant rate. If V of t gives the volume of the balloon at time t, and this is V prime, they basically want to know what time does the child begin to inflate, finish inflating, or begin to let the air out. So here, the volume of the balloon is not changing. Here, the child begins to inflate. That's time equals 3 seconds. And on this whole interval, the child is inflating the balloon. The child finishes inflating the balloon here at t equals 9. Then the child holds the balloon, and it's full, and the child's having fun looking at it. And then all of a sudden right here, and for this amount of time, the child lets the air out of the balloon. So it looks like at time equals 14, the child lets the air out of the balloon. And I'm assuming these are all in seconds, but I'm not sure it says. And if it doesn't say, then you don't have to give units.